Okay, so there's actually three things we want to demonstrate here. What we have is an electrolysis cell, and for a lack of a better word to the right of it, what we have is an accelerator, an electrolysis accelerator, let's call it. So what we're going to show you here is three things actually. Resonance, we're going to show you something called electron avalanche. You might want to look that up on the internet. And the last thing I want to show you is the acceleration process. Okay, so basically this cell here is a very, very weak cell. Okay, we're going to run it on 12 volts. It's designed to be weak only because it's the only way I can show it to you. Normally things happen so quickly. If you have a substantial cell, let's say that produces a liter a minute, you won't really be able to see what's happening. But with this weak cell, we can see this. So we're connected basically to a computer power supply. Here, we'll turn it on for you. And basically, you probably can't see it. It's a low resolution camera, but we're running around 12 volts. And right now it's not connected, or at least it shouldn't be. This again is our electrolysis cell. Our accelerator, which is connected to a voltage regulator. Okay, everything here is homemade, so you'll have to bear with me here, but voltage regulator is adjusted with this dial, and we're going to be running between 0, I'm turning the dial right now as you can see, we're going to be running between 0 and about 100 volts. There's 100 volts right there. Again, it's a low resolution camera, so you won't be able to see too much. But the first thing we want to show you then is let's take a look at resonance. Okay, so let's move the cell right up to the right up to it and start turning on the power. Okay, so what I'm going to do is slowly start raising the voltage to the accelerator, and what you'll be able to see now is the water, or the plates, actually resonating and the water undulating. What you'll be hearing is the resonance. I just turn the power down a little bit to stop it, and we'll start it up again. Again, you'll be able to see the plates resonating. Those are actually the inserts, the plastic inserts that are that can actually show the resonance of the plates. There they are. They're starting to move. We're turning up the voltage for about 70, 80 volts. And again, we'll show you this once more. The water beginning to resonate or to undulate. So there you've seen it. Okay. The second thing we'll do is we'll connect the cell. Here, let's just hook it up here. And you'll be able to see electrolysis occurring. And this is, again, it's very, very weak solution here. Very minimal electrolysis, but again, just enough to show you what's going on. So the next thing I'm going to show you is, again, I'm going to start increasing the voltage. You're going to see something called electron avalanche. I'm going to do this slowly so you'll be able to see it. Now, as a matter of fact, I'm going to do it in spikes for you. There's a large spike. I turned it back down again. I'll spike it again, just so you can see again what is actually occurring. It's actually very violent. It's a very violent reaction when you see electron avalanche. So as you see, we've got an overabundance of electrons in the cell right now. That's really what's occurring. So I've turned off the accelerator right now just to let things cool down. The cell is still running. Okay, it's producing very, very little because that's really the only way I can show it to you. Okay, but now again, what I'm going to do is I'm going to give it a jolt, and we'll run it at about 100 volts. Okay, well, let's just see what it is. Let's just watch. Turn it down once more, and we'll try and show it to you one more time. But that's basically what it is. Now, normally, if you let this accelerator, what you can basically do is, if you've got a cell that produces a liter a minute, it could quite easily produce 10 to 15 liters a minute. That's exactly what this accelerator does. Okay, it increases the rate of acceleration by 10, maybe 15 times. The only way I can show it to you is using this cell, but let's do it one more time just to show you. We have it turned off, so right now what I'm going to do is turn it on again, and again show you electrolysis acceleration, and it's basically caused by, again, electron avalanche. So let's try it again. Take a look at it. So we've turned everything off. Again, our cell is still running. And that's pretty much it.